All right, we're going to talk about static electricity now, and to save time on this, I'm going to show you directly from the key instead of writing it out as we go, just because it's all drawing pictures, okay? And so it's really not that crazy. It's just showing how do the charges change or how the charges move around and stuff like that. So for example, if we look at this first example right here, right? We initially have a plastic sphere in the vicinity of a metal sphere here, okay? Initially, there is, they have an equal number of positive and negative charges, which means that they are neutrally charged, okay? Now, if we bring a positively charged rod in between the two spheres, or I guess near them, right, then what you're going to notice is on the metal sphere, all the negative charges are going to want to be near those positive charges, so they're going to go over there with them, okay? And then the positive charges are going to want to go to the other side of the sphere because they don't want to be near the like charges, right? So they're going to go to the other side. Meanwhile, the plastic sphere is plastic is a insulator, which means that these charges can't move as freely, right? So the plastic sphere is just going to kind of stay chilling, okay? And then the metal sphere is going to have this change. But when the rod is removed, the charges are going to go back to being how they were. They're going to continue to have their charges distributed throughout their surface wherever they please, right? Okay. So there's that example. Pretty straightforward, right? You just notice like charges are repelled and opposite charges are attracted to each other, okay? Okay, this next example has a plastic sphere and a metal sphere hanging from insulating threads, okay? Which means that there's no charges on the threads, or I guess if there are charges, it's not important to the problem, okay? The metal is partially hollow, so both spheres have the same mass and radius, so they both have the same mass and radius, okay? That's just important to note for it. And if you take a positive rod and place it between the two spheres, then what's going to happen is the plastic sphere is going to be unaffected because it does not feel, the charges on it can't move around to shuffle themselves around so that the attracted charges are on one side and the repelled charges are on the other side. So it's not really going to do anything. However, the metal sphere, which is the one on the right, which I did not label, okay, so I'll do that. The metal sphere on the right, okay, the charges can freely move around it, meaning that the opposite charges are going to be pulled towards the rod, and it's going to have an attractive force, which will actually cause the metal sphere to swing towards the rod. Okay, I have it here that's touching the rod. It probably won't actually do that. I'm just not very good at drawing. Okay, or planning. Okay, so there's that. Okay. This example down here, we have two metal spheres, X and Y, placed far away from each other. I'm only drawing, you can assume that both of them have an equal number of positive and negative charges. I am only drawing the charges that are important to illustrate the point. So for example, both of these spheres have positive and negative charges on them, but I'm only drawing the charges that maybe are being affected by the rod, okay? So you would notice that right here, they are initially far away from each other. If they're far away from each other, and if it tells you it's like, oh, the two spheres are far from each other, then it means that they are at a distance such that they do not affect each other, okay? They can't have an effect on each other. If you bring a negatively charged rod near X, okay, X is positive, and they both have positive and negative charges on them, but only near X, you're going to notice that the positive charges are going to be attracted to the negative rod. The negative charges are going to be pushed away, okay? Now, that kind of gets kind of funky when you throw sphere Y, and if you bring sphere Y close to touch sphere X, what's going to happen is when you connect them, they are now considered one object, and so the charges that are repelled are actually going to keep going and push themselves into sphere Y and go to the opposite side of sphere Y, okay? So you've got all the positive charges in sphere X, and you've got all the negative charges in sphere Y, okay? Now, sphere Y would have probably, their charges would be contributed with X. I'm not too concerned about that, right? We might be able to say that sphere Y is initially uncharged, right? But you will notice this, and then if you keep the rod there and you take Y away, what you're gonna notice is that all the negative charges are still on Y, and all the positive charges are still on X. So then you end up having all the positive charges on X, all the negative charges on Y. This is what we call charge by induction, because what's happening is the charged object is the charged object is not making physical contact with anything here. So I know you're like, hey, wait, sphere Y and X are touching, right? Yes, they are in contact with each other, but the charged object that's inducing the charge did not make contact with anything. And that's the rod, right? It just moved the charges around so that it can give them a net charge, right? It doesn't actually touch any of them to give them the charge. It just used its electric force to pull the charges one way and then push the other ones onto the other sphere. Okay. Again, there was no physical contact here between the charged object and the spheres. It was just induction. Okay. So that's charging. That's an example of charging by induction. Okay. This first one up here is a charging by contact example. So there actually is contact between the charged object and the other uncharged objects. Okay. So you have 3 metal spheres initially far from each other. Sphere X has 8 units of positive charge, okay? And so what's happening is we can say that these other 2 spheres have a 0 net charge, or they're neutrally charged, okay? If you bring sphere Y in contact with sphere X, what's going to happen is the charges are going to be equally distributed between the 2 spheres, okay? And that happens if there's no other electric fields or forces at play. So if the 2 are in contact, they're now going to split those 8 positive charges. They're going to split those 8 between themselves, which means you're going to end up with 4 on each sphere, okay? They separate again. Now, in the next one, what's going to happen is Y is going to go to Z, okay? When Y goes to Z, they're going to share the 4 that Y bring to the table. They're going to share it amongst themselves. So what's going to happen is Y brings in 4. They're going to share it. So now each of them have 2. Okay. Now we move sphere Y back to the middle. So now sphere X and sphere Y are going to touch again. But this time, again, they both have charge, which means they're going to divide that total charge between themselves. So you've got 4 units on sphere X, you've got 2 on sphere Y. When they touch, that's a total of 6 charges between them, or 6 units of charge between them. They're going to split that down the middle. So X is going to get 3, so X is going to give 1 to Y, and so X is going to give 1 to Y, and they're both going to have 3, okay? When we move Y back, we're left with 3, 3, and 2. That's charging by contact, right? You notice that a charged object made contact with an initially uncharged object and gave it its new charge, okay? Okay, this middle example right here shows you how wires can be used, okay? Wires, especially in examples with spheres like this, are like bridges, okay? They basically can connect 2 spheres even if they're not near each other. So for example, we have sphere Z, which has a negative charge. Sphere Y is neutral. Sphere X is also neutral, okay? But I'm just drawing the charges on charge Y to illustrate the point to you. If you connect a wire from X to Y, then what's going to happen is you're going to notice that all the positive charges are attracted to the negative charges right here, right? The negative charges don't want to be near them, so they're going to go away from it, okay? We put a wire between them, and the wire is a bridge. So what's going to happen is those negative charges are going to get on the bridge, and they're going to get across to X, okay? So it's basically like they're in contact, but they're not actually, okay? Then if you leave the sphere here and the wire there, you take the wire away, then now these negative charges can't cross back over. They don't want to anyways, okay? And the positive charges are still on Y. You take away the sphere Z, now you've got a negative charged sphere and a positively charged sphere, okay? Okay. Now, here's an example with grounding, okay? A plastic sphere and a metal sphere are near each other. They're initially uncharged, which means that they have a neutral charge. They have a net charge of 0, right? If you bring a negative rod between them, you're going to see the same phenomenon we've seen. The metal sphere charges are going to shift around so that the opposite charges are attracted to the rod. The plastic sphere, they're just going to be chilling. They're not really going to do anything, okay? If you ground both spheres, okay, the plastic sphere, nothing's going to happen because the charges can't move around, okay? The metal sphere, what's going to happen is the positive charges are being held here by the negative rod, but the negative charges are going to go to ground. And when they go to ground, they're going to go into the earth, and they're going to spread out throughout the earth, okay? So they're going from a sphere that may be about this big to a sphere that's as big as the earth, okay? And you can imagine that when that when that happens, you've got these teeny tiny little charges that have the whole Earth to traverse. It's a lot, okay? If you take away both the connections to the ground, then take away the rod, you're going to be left with a positively charged metal sphere. Now, if you decide to remove the rod before the ground, okay? So right now what we did was we removed the ground before the rod, but if you decide to remove the rod before the ground, okay, what's going to happen is when you take the rod away, the positive charges are then going to go into the ground because the Earth has its own charge, right? And it's going to flow towards the ground, right? Most charges, they seek the ground, okay? That's kind of what they seek, right? So just understand that charges will usually seek ground. I mean, pretty much all the time, right? Unless they're being held there by another electric force, okay? So that's just the note that I made here. If rod is removed before ground, metal becomes neutral, okay? Okay. Electroscope example. The electroscope has an initial charge. It's negative, right? It's got all these negative charges along it. If you bring the negatively charged rod near the ball, it doesn't touch the ball, okay? Then what's going to happen is the negative charges are going to go to the leaves, and the leaves are going to separate, okay? If you remove the rod, then the charges are going to go throughout the electroscope, and if you bring a positive rod near it, then all the negative charges are going to come up, and there's going to be no charges left in the bottom leaves, right? We're saying that it only has negative charges. There's going to be no charges left in the leaves, which means that they're just going to close up because, again, I mean, due to gravity, right? I don't think I need to explain it too much, right? Just due to gravity, okay? Okay, and then here's another example, an electroscope that's initially uncharged. You have a variety of charges on it, okay, but they balance each other out. You bring a positively charged rod, it's going to get all the negative charges up into the sphere and all the positive charges down to the leaf. Now, here's the fun part, okay? If a person who is on the ground or who is grounded, okay, not like in trouble, but like grounded, okay, if they come up and they touch the sphere of the electroscope, okay, I teach high school, I'm not saying that, okay? If they touch the sphere of the electroscope, what's going to happen is the positive rod is going to hold the negatively charged particle, or the negatively charged, negative charges, sorry, I didn't want to say particles, negative charges up near the rod, but now we've introduced ground into the equation, and the positive charges realize that they can actually get further away from the like charges if they just go to ground. So what's going to happen is the positive charges are going to come up through the stem and through the person's finger and then down to ground, okay? And then they can get really far away from the positive charge, from the like charges, and they don't have to worry about them ever again, okay? So the positive charges go through the person to ground, and then when the person removes their finger, you still have your negative charges. When you take away the rod, the negative charges go back to just chilling around on the electroscope. Okay, that's how you do it, okay? All right, that's just some examples of how static electricity works. All right, have fun. Girl, boss it up.